Top audio.
Is it working?
Yeah. There's nothing playing on his desktop.
All right, so are we live?
Yeah.
Okay.
It's supposed to look like this.
All right, hello stream. Can you make sure it's working on the other end, Christian? Christian? Can you check the Twitch? All right. Oop, Amber alert. Good time.
My phone. Instead of phone, you can't fly us.
You did download
Okay.
one, right? Yeah.
All right. So today I'm going to be talking to you about programming for your games with and trying to optimally use C#'s features that they have built in. I know a lot of people just learn C# just in the context of game programming, and then you miss out on a lot of the features that C# has to make your code better, cleaner, and a little bit more useful. Before I start though, I want to go over some vocabulary that I'll be using, so make sure y'all are on the same page. So, do any of y'all know what I mean whenever I say an instance of an object? Do y'all know what that means? Are y'all familiar with that terminology? So, in programming, you write classes, especially in Unity. We'll write mono-behaviors specifically, which are a type of class. And an instance is whenever we create a version of that class. And in Unity, that means whenever we add a component. But you can do that outside. You can construct instances. So ownership of parts of your class, these methods, are owned by instances and not by the class itself. So you create an instance of it. So really a class is more of a template, and an instance is a version of that template. Does that make sense? So I might have class bottle that defines what a bottle is. It holds water, right? It has a drink method or something, right? And then an instance of the bottle is like my water bottle here. So that's what an instance is. We can also have class ownership, which means that it's owned by the template itself. And that's a little bit different. I'm not going to go into too much detail, but I'll be using the word instance a lot, so it's pretty important to know. Next, I'll be using the word field a lot, and that's kind of a personal choice. Some people don't say field, they just say members and stuff like that. I tend to say field, and that means something that belongs to the class. So this cap is a field of my bottle, right? More real example, if we look at a class in here, we'll go into more detail on this stuff in a minute, but if we look at a class here, it has a few fields. It has, oops, these are actually not a good example. Let me get you a better example. In gems. So gems has a value field. And so it really is a variable that's owned by an instance. So again, an instance is a version of it, and the version has data members. It has fields that are owned by the instance itself. So you see this float is owned by the class. Okay. Next up, methods versus functions. So do y'all know what methods are? Okay, so methods are just they're things that do stuff, right? We write them all the time. If you've written Unity code before, you've written an awake, that's a method. An update, that's a method. They're just owned by an instance. Again, so fields I generally say are variables that are owned by the instance, and then methods are behaviors owned by the instance. So they're little behaviors like that. So whenever I say method, I mean something like this. We can talk about functions. Functions are a bit different. They're not owned by an instance of a class. But it's not important that you know what a function is per se. I might say function whenever I mean method as well. Just keep in mind, generally we're talking about methods. And then we'll also be talking about references and values. So I'll get into more detail about reference and value later whenever we actually look at examples. But every class, we're actually looking at a reference to the class. We're not actually looking at the class itself. So we'll get into more detail about that in a minute. But what that means really is I have a handle onto an object instead of I actually have the object in my hand. And I know that's kind of vague and hard to think about, but we'll get to it in a minute. Okay. So why is this stuff important that I'm going to go over? It's really, it'll allow you to write more modular code, and it'll also have it be so that you can protect yourself from making dumb mistakes. So a lot of this stuff is writing code so that you can't break stuff that you've made. And that's really important in programming, especially whenever you have big projects. You might have written some code in the past that like you just forgot what this thing does and you change it and it breaks everything. So you want to prevent yourself from making these poor design decisions. So that's why we're going to talk about some of these stuff. To get started, I'm going to get a little technical right away, and I'm going to talk a little bit about attributes before I do anything else about like stuff, because you'll see them in my code and I'm not going to explain them whenever I go over them. So attributes are basically just labels, and I'm just going to go over them really quickly. They're not super important. Just know that they exist. You'll see them up here. They have little square brackets.
Hey, can you zoom into your code?
I can zoom into my code, I think.
Controls.
Yeah.
There we go.
It's kind of laggy. Okay, so you'll see this class, this player class, inherits from mono behavior. This means inheritance, the little colon. And you'll see that these fields, this money field, has a hide and inspector attribute. And that's just a label. And these labels tell Unity to do something about this. So the hide and inspector attribute, anybody have a guess what that does? Somebody?
See it in the inspector.
Wow, genius. Yeah, so basically you normally have these public variables in your code, and then you modify them in the inspector. So you'll see if I look at the player up here, we can look at our player class, and then in inspector, we look at our player component, and you'll notice that there is no public float money. And even though it's public, normally public is serialized, which means it's in this case it means that you can view it in the inspector. Not in this case, because we've hidden it. We've said don't look at this. You'll note also that if we look at an inspector, speed is visible. But speed is private. So anybody have an idea what this serialized field does?
Is it visible?
Exactly. So we can expose private things with serialized field, and we can hide public things with hide and inspector. So these are just two examples of attributes. There's a lot of them. They can go onto fields, and they can also go into classes, and they can also go onto methods. So you'll see here in the gem class, I have a couple of attributes on top of my gem class instead of on top of a field. And it has a require component and an add component menu. I'm not going to go into too much detail. Basically, this keeps me from making the mistake of not having a collider on my gem object. If I give a game object the gem component, it will not let me do that unless I have a collider. And basically, I'm saying I require a collider for this to even work. So if you don't have a collider, it's not worth your time. And that's another one of those things where I'm protecting myself from myself. I don't want to make the stupid decision of putting a gem onto a game object and then not having a collider and everything breaks. And I'm curious, like, why is everything breaking? It'll just instantly tell me, hey, you don't have a collider. You can't do that. All right. So now we get into the more detailed stuff. So, oops. Okay, so if you'll want to look at this project, I'm going to go over some examples first, but the idea is we're going to make a little gem class, and it's going to have an inheritance structure, which means that we're going to have child gems that do interesting things. We can decide on what those interesting things are in a minute. But you'll see here, if you'll play this game this scene that I've created, it has a little money counter up at the top. We have this knob in the center, which is our player, and then we have a few gems scattered around. So if we play the game, you'll notice that we just pick up these gems and our money counter goes up. Very simple. If the game will play, we'll see. Oh, okay. So you see my money goes up whenever I collide with these gems. And let me show you the gem class very quickly. So this is the gem. We'll get into what this means in a minute. But you'll see it's very simple. It has an onPickup method that just increments the money and it destroys the game object. And unsurprisingly, this is called whenever the player collides with the gem. So very simple type of behavior. Okay. So we're going to talk about inheritance because while we have this generic gem, we might want to have gems that do interesting things. Maybe we want a gem that explodes, or a gem that gives you money upstart, but then like does damage to you, or something like that. So we might want like children's of gems, different types of gems. So we have a generic gem right now. Maybe we want more detailed gems. So that's the problem we're trying to solve, and we're going to solve that with inheritance. And we'll look at this. So, all right. Actually, I'm not going to go over this right now. So this is a C# specific thing. Y'all don't really need to know this if you're writing stuff for Unity, unless you want to like create C# objects, which you can. So if we just have the class name like that as a method name, it's actually creating a constructor, which is called whenever the object is created. Now, Unity does not support constructors. We use things like start and awake, and that kind of is similar to what a constructor would do. The difference here is that a constructor is like, it's on the instantiation of an object. And the problem is that Unity is actually behind, like in the background is actually like running in C++. And so it's not actually using like these C# objects, it's using their own system. So that's why constructors are not supported. If you have a mono behavior, the constructor won't necessarily be used. What's up?
Zoom in.
Okay, yeah, let me zoom in.
Yeah, like you can make sure your text is visible.
Yeah. So that's the constructor, and you'll see on construction, so whenever I create an instance of A, so whenever I make a new A, it'll print construction of A. And then it has a few methods, as I mentioned earlier. They'll just protocols that do things. Foo, which just says a foo, bar, which says a bar, and don't worry about it too much. It's protected, so it actually cannot be called outside the context of the public context. So it just prints a. So if we look at these test cases that I wrote, this here is how you construct an object in C#. So do y'all remember what's going to happen here whenever I construct an A? What's going to happen?
The print construct an A.
Yeah, it's going to print construct an A, and then so on with foo and bar. So if we look at the output real quick, oh, oops, I forgot to, 1 second. I need to add the test object. Oops. Okay. I'm just running these commands on start so that way we can see them. Okay. So it says construct an A foo, a bar. Okay. So nothing unexpected there. All right, now things get a little bit more interesting. We have a class B. So we were looking at class A before. Now we have a class B. And does anybody remember what the colon? I briefly mentioned what the colon means. We always do it with mono behavior. We say colon mono behavior.
B inherits.
Yeah. So A is the parent class of B. So what inherit that means is B receives all of the members and all of the methods of A. Okay. So you'll see there's actually a special syntax in the constructor. Because I have a default constructor, which means it's a constructor that takes no arguments. We can put arguments in there, parameters. I don't actually have to put this base thing. So if y'all are familiar with Java, super and base are analogous. They're the same thing. Except for C# uses base and Java uses super. So base is how you would access members of the base class or the parent class. And you see here on the line where I define the constructor, I have a colon base, which calls the parent's constructor. So I'll be calling the parent's constructor before I call my constructor. And that's just the rule. You have to construct a version of my parent before I can construct a version of myself, because I am a type of the parent. So whenever I build a B, I'll print construct a B. Nothing unusual. And then so on and so forth. And I did the same things for B as I did with A. So I constructed a B in our test cases. It's a type B. And I have a b1.foo, b1.bar. So I call those methods. And you can see here that it actually constructs an A first, which is what happens. Always call the parent's constructor. So it'll construct an A, and then also construct a B on top of that. So it runs both of those lines of code, even though it's the same instance, the same version of that object that's constructed. So they both are called, and then B's foo and B's bar is called, which is, again, very expected. This last test case is where things get a little bit interesting, and we can see a little bit of like why we use inheritance. So A2 is a type A object, but we've created a B and assigned it to A. So we can do this because B is an A. So you can see here that we've constructed a B even though we're assigning it to an A. And then we're going to run the foo and bar methods. And this is going to be a little bit confusing if we look at the output. And that's because I haven't told you something yet. But you'll see that whenever that happens, we construct an A and a B. As expected, we're running the B's constructor. But we run A's foo and B's bar. Even though this is an A object, why is it calling B's, or was it A's? I forgot which one's which. Yeah, so it's calling A's foo and B's bar, even though we're running it on the same object. So this is important because sometimes we want to have general things. Maybe we want a list of gems in our gem scenario, and we want to run the on pickup for all the gems. But that might do a different thing depending on what type of gem it is. So we don't want to run gems pickup. We want to run whatever the child class's version of pickup is pickup. Does that make sense? So maybe the pickup says blow up the gem, right? Well, we want to run that instead of gems, whatever it is. So gems right now just increments your money. So if you pick up a bomb gem, you don't want it to just give you money. You want it to blow up, obviously. So what's happening here is we have to mark certain methods as virtual. And that says, I plan on this method being overridden by my child class, and I will refer to the right one. And what I mean by right one is I will refer to the child's version of this. So you'll see here in A, foo is not virtual, but bar is. So it ran A's foo because the actual type of the object it was looking at was an A. So it just treated it like an A, and it ran the A's foo. But it noticed that bar was virtual, so it looked up the actual object and ran the actual object's bar. So if we were to mark this as virtual, it would run both B's. I'm not going to do it because I don't want to rerun the test cases, but it would run both B's foo and B's bar. Does that make sense?
What does override do?
So override is whenever we're in the child class and we want to define the actual, we're saying we're overriding the definition of.
So would you need it also to put override in B?
So override is just you acknowledging that the previous version of bar was virtual, and I want to redefine it. I want to make it the child version of it. That way you'll know which one to refer to. So you have to put this override keyword. It's not true in Java. In Java, everything I think is virtual.
So if you put virtual and then you don't put override, will it override?
Wait, say that again?
So
actually it'll be a compiler error.
Virtual for A foo, but then put override for B foo, would it do A foo, B foo?
So you have to both mark it as virtual in the parent and override in the child. You have to do both.
Okay.
Otherwise, it won't compile. It'll tell you that's an error. You can't do that. Yeah. So that's a basic overview of very basic inheritance. Do y'all have any questions about that? All right, so I want y'all now to write a new gem. And I'll write it with you. So we'll do that real quickly. Let me just collapse this real quick so we don't have to look at it. All right. So we have this gems class. It's very simple. I didn't go over interfaces yet, so I won't talk about it. But we have an on pickup, right? That we'd like to later override by our children. So we want to make that virtual. So that's the first thing we're going to do. We're going to say, hey, actually my children gems are also going to have this. And we can give it this default implementation. So this is just, if it's a raw gem object, this will be fine. But now we can create a new gem object. Y'all have any ideas? Any cool gems you want to make?
A purple gem.
A what gem?
A purple gem.
What does a purple gem do?
Strictly purple.
Does it do anything interesting?
No, it's only purple.
I'm just going to call it purple gem.
Purple gem.
So we're just going to have it inherit from gem. So because gem is a mono behavior, purple gem will also be a mono behavior because it still inherits from mono behavior. So it's still going to be a unity object. So we just don't care about constructors or anything like that in this case. Okay. So now we can override the pickup method. I cannot type. And I think the stuff that we were doing before in the parents version is still stuff we want to do. Like we still want to add the money to the player, and we still want to destroy the game object at the end of the day. So does any of y'all remember how, well, I didn't really explicitly say this, but I kind of mentioned it. There was a special keyword that lets us access our parents version of something. Yeah, so if we use base, we can use base dot on pickup, and now it'll do the same thing right now. Right now it's just calling the parents version, but now we can add interesting behavior before this. So
Make the player purple.
okay, so we can do that. We can do, so I've created a singleton. I'm not going to explain what that is, but I can access my player like this, player.instance dot, and then we can do get component sprite renderer. This is very Unity-esque. So we can get the sprite renderer, and then, oops, dot color, oops, equals color dot purple.
I don't think there's a predefined purple.
There's a magenta though. Okay, so we'll make it magenta. Close enough. It's a magenta gem. Okay. So now we've created this new gem type. I'm going to leave this up for a second and check out. How's it going?
A lot of errors.
I can't.
Highlight everything that you typed. It helps bring it out.
Yeah.
Oh yeah, and zoom in.
Okay.
It probably makes the color line 2 lines.
Yeah. Good call. Okay.
Oh.
So you see this is a very basic class. And this is the power of inheritance, by the way, is it lets us write these very basic behaviors for stuff we already know how to do. So we don't have to reinvent the wheel here. We don't have to do a lot of the stuff that Gem already does. We can just add the behavior we want, and it's already good. Okay. So I'm just going to quickly make one of these gems a purple gem. Oops. So we can create a new game object. So I'm just going to create a new 2D sprite. And then we'll use this hex sprite that I have. We'll make it smaller. Maybe much smaller. Okay, let's move it around. So here's our gem. We'll make it purple because it's the purple gem. All right, and you'll notice if I try to go here, if I go to purple gem. Oops, it cannot find it. Let me make sure I'm saved.
Oh wait, no. Ian, you need to make a new script file.
It should be able to detect them if they're the same.
No, you have to put scripts in their own files. It's not able.
I've done that before,
Unity's
though.
Detection does not work if you
Okay.
put classes in the same file. And it has to be called purple gem too.
I know.
Exactly.
But I've gotten that to work before, honestly. I don't know.
I've had it work and then decide to not work too. Like I've had it done halfway bullshit.
So yeah, if you move it to a new file, you're gonna have to use this namespace I have called egads. Hello, autocomplete. Would you like to help me? All right, I'm just gonna copy it. All right, so if we have a namespace there, everything should work. And we'll just copy this. Oops. We need the whole class. Oops. What did I do? Okay. I'm not in play mode. What are you talking about? Okay. Hello? Right. All right. Oops. So you'll see if I try to add a purple gem, it's going to yell at me. Because if you remember, I required it that it had a collider. I had that require component 2D collider. So we do need to add a collider. So we'll do that. And see, this prevents us from making it the error, and we'll be wondering why it's not working. Well, obviously it won't work without a collider.
Wait, I'm lost.
What's up?
You go to making the new file.
Okay, so I created a new file called purple gem. All right, and then I opened it up. I deleted most of it. That's the first thing I do, most Unity scripts. And then I opened up this namespace, egads tutorial. And that just creates a scope where all my stuff exists in. So that way, like, it's a shared space. You don't really have to understand it, just use it in this case. And then I pasted the purple gems class.
Watch your time.
What am I at? Oh boy. Yeah, I don't know if I'm gonna be able to get to half the stuff, but it is what it is.
Basically just prioritize.
Yeah, I mean, it's fine. I think it's going to work, yeah. You got it, Grant? Did everybody else get their purple gems to be addable to your game objects?
Go back to this.
Back to where? Right here? Okay.
What are these hands?
What's up?
So when you do override, right, is that required or is it just like
Yeah, in C-Sharp,
syntactic
it's
to do-
required.
Okay,
In Java, it is not.
cool.
How do you change it?
Hmm? What's up?
How do you change the gem gem?
Okay, for some reason, it's saying this for my object, and I don't know why.
But it's making it
Kind of right. It was like that.
So so the first thing I did was I marked on pickup on gem as virtual. Remember, it has to be marked virtual, so you have to mark it as virtual.
Yes.
Thanks.
You good?
I didn't.
No.
What's up?
How do you make it purple gem?
So you add the component purple gem. You remove the gem component. You don't want that.
What, what's this?
Just remove the gem component and add the
Why is it
purple
not working
gem.
now?
What's up?
Oh, it's still not working.
I would just create a whole file.
Yeah,
Because then it's a CSharp, it's like missing your
Goes.
Okay.
Oh.
So just like right.
Wait, no, that's not
And
working.
you click on this right button.
Oh, look at Jim. Wait, no, what?
Oh, God, you're right. There's no alert.
Wait, were you not doing it? Were you not doing the thing? Yeah, but like that.
Yeah, so if you don't use namespaces, it's shared in the project namespace. But if you use a namespace, I'm more specific. Like this is the area of stuff. You can also put using at the top of the namespace. Like maybe this is
Were we supposed to cut? Or were we supposed to copy?
cut.
Cut? Okay, my bad.
You can just delete it. Fine. You can't have two exist. You have to have one. Has everybody got a purple gem kind of? What's up?
I basically went to prefabs, got a gem, cooked it, and then made it purple. I'm pretty sure that's not how you're supposed to do it though. Make sure to say we get rid of the script control exchange for
I would recommend not copying the prefab and creating a new object. Because prefabs are things. Okay. So now, it should be the case, let's hope that this works, that you turn purple if you touch this gem. And you do. So now we can turn ourselves purple when we touch purple gems. And it did give us the money as well, which is good. That's what we wanted. Go around, collect all these gems. Okay. So we have like 15 minutes. So I don't want to I have a lot of stuff I can talk about, so I'm really more interested in what y'all are interested in doing. So, yeah, so I can explain these topics very vaguely, and y'all can tell me what y'all are interested in doing. If y'all want to focus on inheritance more, there's a lot more you can learn. We do have this interface up here I can talk about for a little bit, and then a little bit more stuff about inheritance. We can also talk, here, I'll just show you all the things. So these are the things. Inheritance, this is what we just went over. There's an inheritance 2 region I can show you, a little bit more detailed stuff about inheritance. We can talk about the different types of objects. So we've been talking about classes, and this is where I'll start talking about references and stuff like that. If y'all are more interested in that, I can talk about structs and classes and ref and out keyword. We can also talk about properties, which are really useful. I think that's probably, if y'all don't have an opinion, this is what I would recommend. Just because it's syntactic stuff, it doesn't actually do really anything for you, but it really makes your code much cleaner. So that's really nice. And then we can talk about delegates, which if y'all know lambdas, are like lambdas. So any opinions about what y'all like to learn? We can continue with inheritance too, which is good. The next stuff about inheritance is literally just mentioning, I'll mention these anyway, but interfaces and abstract classes, which are just a little bit of extra for inheritance. So do y'all have any opinions, any thoughts?
Take a hand vote.
I think I'll just...
What is struct view classes?
Yeah, okay, we'll go over struct view classes then. But I'm going to quickly mention these because I guess it's important. So just vaguely, abstract classes, you cannot create an instance of. So you wouldn't be able to add the component if you're using Unity. If you had an abstract class, you wouldn't be able to add the component to there because you can't actually create an instance of it. But you can mark methods as abstract, which is like marking them as virtual, except for it has no implementation. So you notice in virtual, I had to give it some implementation to start with. Abstract requires that the child class implements it. So I'm saying, as a child of this class, I have to implement foo, right? I don't know what foo does, but you as a child, you better know what foo does. And then quickly, you'll see in the test cases that D is actually a child of C. C is abstract. So if we create a C, we can still have a C on the left-hand side. We just can't create an instance of it. So we create an instance of D and assign it to C, and then we run D's foo and var. The thing about abstract class, you'll notice that it also has this normal bar method, which like previously, it's just a normal method. So you can have implementation in an abstract method, but what makes an abstract class is that some things must be implemented by the child. So this is not this has some implementation in it, but it also has some non-implementation in it. I'm deferring the implementation to the child. I'm saying, as a child, you have to make a foo. Because I don't know what foo does. You better. And then quickly on interfaces. Interfaces are like abstract classes, except for they have no implementation. So I'm basically saying, if you're an IC, you have to have a foo, and you have to have a bar. And that's it. And they're really useful because normally in inheritance structures, you don't want to have, you want to make a tree. You don't want to have multiple inheritances. So you don't want to say IC, DC, or something like that. Or D. Like, you don't want to inherit from multiple things. I don't want to inherit from both A and B. I just want to inherit from B. Things with interfaces, because there's no implementation, there's no chance of collision. There's no chance of me breaking something, like inheriting a method from two different parents that like overlaps and breaks something. I have no chance of really doing that because I'm just saying I have to have these things. So it doesn't really matter. So you generally have like interfaces to say, I'm capable of doing something. So that's the use case of interfaces. And actually, Unity has been kind of moving towards using a lot of interfaces. There's some built-in interfaces, like if you all are familiar with event systems. Event systems actually use interfaces to interact with the world. If you're interested in that, I can link some stuff. There's like, if you ever want to do like dragging events and stuff like that, you'd have to use an interface. And you'll notice that in the gem class, it's both a monobehavior and an igem. Because igem is an interface, I'm not worried about multiple inheritance. But while monobehavior is just a parent class. So that's very short, very quick. I'm sorry if that's a little rushed, but now you know they exist: abstract class and interface. And of course, this code you can look at any point in time. All right, next up is, where was I? I'm lost. Okay. Where's this? Okay, region inheritance too. All right. So next we'll talk about structs and classes. So we've been writing classes right now. And this is where things get a little complicated, I'm sorry. But you'll notice that I have, oops, what's this? Okay, yeah. So I have a class here called CLS, which is the abbreviation of class. And I have a struct. And they're both written in the exact same way. They both have these two fields, name and value. They're just two fields. They're string and int. And then they have a constructor that takes in a string and an int and assigns it to name and value. And then they have a toString, so I can print it out and see what they look like. That very simply prints struct, name value, and class name value. Now, they're both objects in the same way. An instance is treated very similarly. So if I have an instance of struct and an instance of class, you'll notice here, like this, I can access the members in the same way. So I can do print sti.name and print cl1.name. Right? They're treated in the same way. So what's the difference? The difference is really behind the hood. And what, if y'all are familiar with primitives versus classes, again, a little iffy. The difference is, realistically, structs are passed by value and classes are passed by reference. So what that means is a struct, every time I give it to a method or something, I'm actually making a copy, and I'm saying, here, have a copy of this. So generally, structs you want to keep nice and short for that reason, right? If I'm passing it around, it's going to make a new copy. And there's no shared data. I'm just saying, hey, here's an instance of this struct. Have it. While a class is accessed by reference. So if I give you a version of my class, you're looking at the same class as I am. So if I'm in method A, looking at class C or whatever, and then in method B is also looking at the same, I pass in to method B, C, we're both actually looking at the same class. While a struct, it would actually be looking at a copy whenever I pass it into B. And I show this here with an equals assignment. So what I do here is I make a copy. So I say st2 equals st1. And because it's a struct and it's passed by value, we make an actual copy here. We say okay, copy all the members in struct 1, make a new struct, and fill those values. Run the constructor. Well, actually, maybe not, but okay. And then class 2. The class 2 here, actually what we're giving it is a reference to the same class. So if I were to draw a picture, we have our variable. I'm just going to say S and C because S for struct, C for class. And then we have the actual instance of the object. And this is the best way I can do it. I know it's a little bit more detailed here and a lot harder to kind of wrap your head around sometimes. So really, S is looking at the object itself. It's storing the object. So it's in there. It's actually like S is just the object itself. While C is actually a reference to it. I'm saying, I live here in memory in your computer, right? I know where it is, so I can look it up and find it. So whenever I want to access stuff, I know where it is, right? And so if I pass this value to another method, or I do an equals assignment, it's just going to copy this. So S2 equals S really just takes all this, makes a copy, puts it down here. While C2 equals C, what it does is it copies this reference. So it's like, okay, C2 is also just an arrow back up there. So they're like looking at the same object. And so what I do is here, I make these copies, and then I reassign their value. So you'll notice the original value was 0, and I reassign their value to 1 on both the copied class and the copied struct, and then I print it out. So if we look at the output, you'll see that on the struct, the original struct has value 0, and the new struct has value 1, because we've made a copy. While the original class has value 1, and the new class has value 1, because they're actually just looking at the same class. So whenever I modify the value in C2, I'm also modifying the value in C1. But in a struct, that's not the case, because it's its own object. So I know that's hard to wrap your head around, and I don't really have a good example in game programming right now. Generally, they're really good. Structs are good for packaging a lot of a small amount of data, like a couple of ints or something, into one thing. So if you all know the vector2 class or the vector3 class, those are actually structs instead of classes, because we pass them around by value. And they're small, and that means that like we can do things a little bit more efficiently, a little bit more quickly. So that's the difference between structs and classes. And then we can just quickly, I don't think I'll go over this. I'll just mention it, but actually, does anybody have any questions about the gems or anything like that, especially about inheritance? Because that's what we focused on mostly. Any last questions? Any ideas? Anything? No? Okay. I'll just quickly mention the ref and out real quick. So these are just special keywords. If you ever have created a method and you wanted to have multiple returns, this is how you would do it. So out, or I'll do out first. So out, you can specify these parameters as out and pass in things by value. So normally if you pass in a class, right, it's by reference. I can change the things inside the class, and it's fine. Like these changes are permanent because we're accessing the same object. But if I pass in a string and I wanted to get like 2 strings back or something, I can't really just modify the string inside and then expect it to change on the other scope, if that makes sense. So I can't just say string 1, 2, 3 or int 1, 2, 3, right? And then pass it into something and then expect that to change the 1, 2, 3 in the original context. That won't happen. So the out keyword here lets me say, you give me a raw variable that is not instantiated. So you give me a variable that has no value. So like right here, I just create these variables I don't actually instantiate them. I don't assign them any value. And then I run generate on them with this out keyword. So both in the parameters and on the passing in, you have to put the out and ref keyword, which are the two keywords here. And now, after generate completes, I can print ID in new SRT, which is that struct from earlier, because I'm actually creating this pass by value item. And I can actually basically have multiple returns now. So I can have two things come out of it. And ref works in a similar way, except for it doesn't insist that it's empty beforehand. So out requires me to have no values in there beforehand. It has to be an empty variable. Ref lets me pass in whatever I want. It can already have a value, and it'll change the value. So I could pass in the int 123, or I could have new val equals negative 100 here, and then whenever I pass it to modify will change it to -1, and then it'll print out -1 here because the value is now changed. So that lets you have multiple returns, mess around with like that type of thing, and that's about it. So if y'all have any remaining questions or anything, I guess now's the time. We're almost out of time actually, so we have about 3 minutes. I hope this was helpful, at least a little bit. I know it's a lot. It's pretty detailed. I'd highly recommend using inheritance more if you get the chance. It makes things a lot easier and cleaner if you have like a lot of big systems. So that's it for me.